Hello and welcome back to part 5. From the last episode I learned that I should have continued looking into how the container header works, because this automatically reads something by a chunk ID, and that failed, so I ignored it and then continued. But yeah, the chunk ID was a problem because I had this implemented twice. So I made this class here and I had it again in here in the header, and so this function was not present in the other class I initially copied, so that failed at the part where it has to actually read stuff by entry. That would be index read, yeah, read, try, resolve. In here it does some, let's say, complicated hash math, where it does get an index from the seed. With that seed, the figures out a slot, and the slot is the actual chunk that we want to load for the first block of stuff to load. This works like a file system on a hard drive where you have chunks of blocks where's file data, and inside the chunks it's telling, yeah, here's so and so much data, it's compressed or whatever. And so yeah, this works now, and I can read the actual header if I wanted to. It looks like this. Just for comparison, because I don't need this header, but the signature is this hex value, and if I look in reverse, so 49, 49, 6F, 6F, 43, 43, 6E, 6E, or IO container, essentially as ASCII. Okay, and all the rest stuff in here, it's also has hashes or package IDs in this case, and some other data, but nothing I need right now. Instead, I'm actually as far as being able to extract stuff. That means simplifying. So this all still works. I can load the contents, and now let's export this all. So just quick check if I have breakpoint here. This is where we should come out. So yeah, in the main loop that goes over all file names, we have picked one entry and now want to read it as our chunk ID. Oh no, what is it? Store entry, sorry. Which has an offset and size. Okay. And so the block index is coming from first block index. Oh yeah, so these blocks are come in the fixed size, and we can figure out just by the offset which is the first index. Interesting, but makes sense. It's just this number minus the last part, and then we get actual information about this block, what is compressed here. And compression method. So first off we go to the offset, it's here, and this would be Does the stream contain the file name? No. But anyway, it's a ucast file, already know that. Okay. And what is its size? Raw size A70. This is a small file. Okay, that looks fine. Looks kinda compressed, but I don't know. Not really. Let's see what method it says. Okay. I should reload the file. And export. Okay. Is it because I currently have it open? That would be bad. Okay, that worked. Okay, what is this error? Connection was closed abnormally. What? Oh. Okay, never mind. Disconnected. So what is the problem? I mean, can I still open them with the hex editor? Yeah. Okay, that's what's debugging for. Can read. It's not closed. Okay, that is fine. That is not fine. Why is that? And again. Oh, actually going to load. Just export. Seeking is fine. I think this is a problem about Unity not cleaning up, or maybe myself not cleaning up. So bye bye. Let's try that again. Oh wait, what the hell? When did this appear? Okay, let me make a little break here. Alright, I'm back. Don't know why that appeared, but I removed it. So let's try that again. Hello, Unity? What the hell? Ah, come on. Let's try that again. Come on, Unity, do something. What is happening? Oh, I see. No, it's not the real-time protection. Can we finally go back? Man. Okay. Load the file. Okay. We can read data. Okay, finally. Okay, it's a bit much. Wait, this is from getting the container header. This is now yeah. This should work fine because it's just the header. Now export. And you can read data. It looks at least correct. But it is compressed. So top resource, function methods, OODLE. Okay, OODLE is something new, something I have not worked with yet. And let's see how to implement that. As far as I know, it's using a third-party DLL because this is proprietary. But I will see. Reader, yeah. That's where I stopped last time. On Visual Studio. Everything fine except that. Okay, so we have a whole compression class here. Okay, why not? Compression methods. first off, if we don't know the compression, what's not implemented, it's not implemented. So I don't care for most of these. I'm interested in Oodle. If I need them, I can add them later. Okay. Good. So now more stuff missing. Oh, we already have this, then let's remove it from here. Okay, that's fine. And then this is also fine. Great. Too many parameters. Okay. This. Okay, and now let's add Oodle. Very interested in that. Oodle.net. Oh, that's a DLL. Ah, never mind. Yeah, just randomly download DLLs from the internet, why not? I mean... Well, let's download it like they do it here. And this is a static class. Yep. Public static class. quite a lot of code to just download a DLL. Okay. Don't tell me this isn't available. Yeah, okay, scrap that. Bye. This seems to be a feature of the newer .NET Core. Yeah, I'm not using that. Okay, let's do it manually. Please try. Oh, this is compressed. Okay. Nah, this won't work. Do I have a quick fix for that? Convert? I just want to decompress it. What will it do? And I hate those websites. Archive. Actually, I always think it's an archive. It's not. Okay, great. Isn't that nice? Okay, we are looking for what? Okay. Nope. Okay. Let's do that again. We have we have now my new string. Yeah, okay, and that's why we need the header stuff. Oh. Access line. Wait, where was actually... Where is it an R come from? Oh. Is that all? Okay, I will make a cut here, implement all of this, download this DLL, and then we can continue. And I'm back. As you can see, stuff is working now, and we actually get files out now. So let's open this. So these are 4-byte aligned values, looks fine to me. A lot of strings, properly decoded. So this data looks valid to me, not compressed or anything. So how did I do this? I tried multiple things before I got to my final solution here. I implemented UE5, which is just a little class that directly uses interop services to access functions from the DLL. And I got this from UE5, from this guy. Thanks a lot. And go to the main file, please. It was using the older version, number 3. I just changed that, and that's about it. Copied everything else that works. So now in my UDL helper, I can actually use this to decompress the input data. This is now used in the decompression main switch, and finally is used here in the main reading function of files. So right now all the files that are inside these utalk files can be extracted and then hopefully soon analyzed and also extracted from, like textures and models and maps. And yeah, I'm kinda happy this works. So thank you for watching and see you next time.